Hey guys, welcome to this video for chain rule for level 3 differentiation, and that's for level 3 calculus. So what is chain rule? In maths, the chain rule is used to calculate the derivative of composite functions, or more simply, a function within a function. So if you have a function, so f of x within another function, f of x. So for example, if you have y equals to 2x plus 5 to the power of 3, that would be an example of a composite function. So in level 2, we'd probably have to expand and use the power rule to differentiate. But because that takes a lot of time, and instead mathematicians have devised a strategy in order to differentiate these composite functions at a much faster speed. So instead, we can look at this as the outer function and the inner functions. So in this case, the outer function would be the the to the power of 3 on the outside, and the inner function would be everything inside the bracket, which is 2x plus 5. So differentiation using the chain rule. So if we look at the formula sheet for level 3, we'll see this was what you'll see. In that first glance, that looks very complicated, but it's just saying that it looks pretty complex, but it tells us the derivative of a composite function, so that's the f within the g inside the f. So g is a function, f is a function, so g inside f is the derivative of the derivative of a constant function is simply the derivative of the outer function multiplied by the derivative of the inner function multiplied by the inner function. So that's just what it's saying. So the dash means derivative. Alright, so looking at the last example, we have y equals to 2x plus 5 to the power of 3. So we can differentiate the to the power of 3 using the power rule we learned from last year. So take the power to the front, or the coefficient, and decrease the power by 1. So the derivative of the outer function can be simplified to just the power rule, so take the power to the front minus 1, so it becomes 3 times of something to the power of 2. While the derivative of the inner function is just 2. So the inner function is 2x plus 5, the derivative of 2x plus 5, that's just 2. So therefore, we need to multiply by the derivative of the inner function. So we need to multiply by 2 at the end. So what we actually end up with is 3 times 2x plus 5 to the power of 2 times of 2. So that's what we end up with. dy over dx equals to 3 times bracket 2x plus 5 to the power of 2 multiplied by the derivative of the inner function, which is 2. So the 3 at the front comes from the power, so take the power down, and then the to the power of 2 is because the to the power of 3 it decreases the power by 1, and then 2x plus 5 stays the same. Alright, so some practice. So we have y equals to 3 sine 3t, so it's 3 sine of 3t. So the outer function is 3 sine, and then the inner function, so inside, is 3t. So in this case, we can differentiate sine, and that becomes cos, and we need to multiply by the derivative of the inner function, which is the derivative of 3t is just 3. So we end up with this dy over dt is 3 cos 3t multiplied by the derivative of the inner function, which is multiplied by 3. So that will simplify to 9 cos of 3t. Question 2, y equals to 3 ln of 5x minus 2. So in this case, the outer function is 3 bracket ln, and the inner function is the 5x minus 2. So the derivative will simply be the derivative of the ln, which is 1 over 5x minus 2 times by the 3. And then we need to multiply by the derivative of the inner function. Derivative of 5x minus 2, that's just 5. So we'll get 3 over 5x minus 2 times of 5, which is simply 15 over 5x 15 over 5x minus 2. So y equals the square root of 3t squared minus 2t plus 4. So in this case, the outer function is the square root, and the inner function is 3t squared minus 2t plus 4. So in this case, we actually cannot differentiate straight away with the square root, but we know that square root can be rewritten as something to the power of 1/2. And once we have power to 1/2, we can apply the exact same rule we used in our example on the previous slide. We can take the power down, so take the 1/2 to the front, decrease the 1/2 by 1, decrease the power by 1, becomes negative 1/2, multiplied by the derivative of the inner function, which in this case is 6t minus 2. So dy over dx, so you take the 1/2 to the front, you keep the inner function the same, so 3t squared minus 2t plus 4, all to the power of negative 1/2, multiplied by the derivative of the inner function, which is 6t minus 2. Question 4, tan to the power of 4 times of r squared minus 3. So in this case, outer function is tan to the power of 4, and the inner function is r squared minus 3. So So in this case, we can apply the power rule. With the 10 to the power 4, we can use the power rule. So take the 4 down and take the power down by 1. So 4 10 to the power 3, bracket r squared minus 3. But we need to multiply by the derivative of 10, which is sec squared. So we have multiplied by sec squared. Everything in the bracket stays the same. So sec squared r squared minus 3. And we also, because this is like a chain rule within the chain rule, if you know what I mean, you have to use it twice. And we also need to multiply by the derivative of the inner function, which is the inner function, which is r squared minus 3. And the derivative of r squared minus 3, that's just 2r. So what this actually looks like is 4 10 to the power 3. So take the 4 down, decrease the power by 1. 4 10 to the power 3 multiplied by r squared minus 3. Multiplied by the derivative of 10, which is sec squared, bracket r squared minus 3. Multiplied by the derivative of r squared minus 3, which is 2r. And that's our dy over, well, technically it's dy over dr, and that would be dy over dt. Apologize for that, I just realized. Apologize. Okay, questions involving the chain rule. So money in a bank account can be modeled by, this equation. So m of t equals to ln cos of t plus 2t minus 3 to the power of 1/3. Calculate the rate of change of money after 2 years if t is the time in months and m is the money in thousands. Alright, so dm over dt, so we need to differentiate. So the derivative of cos is negative sign, and we know the derivative of ln is just 1 over everything inside the ln. So derivative of ln is 1 over cos t multiplied by the derivative of the inner function, which is negative sine t. So dm over dt equals to negative sine t over cos t, and we need to differentiate the next function as well, which is 2t minus 3 to the power 1/3. So we take the power down 1/3. We take the power down 1/3, and we take the power down by 1. So we have 1/3 times 2t minus 3 to the power of negative 2 over 3, multiplied by the derivative of the inner function, which is 2. So this is what we have, and if we simplify this equation, we'll get dm over dt equals to, I forgot to simplify, but dm over dt is negative 10, because sine over cos is 10, negative 10t plus 2/3, so 2/3 2t minus 3 to the power of negative 2 over 3. Alright, so dm over dt, we have 10 to the power of, sorry, what am I saying? So dm over dt, if we plug in 24, because t is the time in months, and 2 years is 24 months and 2 years. So we'll plug in t is 24. And if we plug everything in and substitute those numbers in, we should get the rate of change is 2.188, but m is the money in thousands, so we need to multiply it by 1,000. So at 2 years, the amount of money in the bank account is increasing at $2,188 a month. Example 2. The graph of y equals to cos 3t plus square root of tan t over 2 has a tangent as t equals to pi over 2. Find the equations of tangent. So in level 2 mathematics, the level 2 calculus, in the differentiation/integration standard, we would have covered finding the tangent at a point, and we simply need to find the gradient at that point, and we need to substitute the y value at that point to find the c value. That's all that we need to do. So we need to differentiate dy over dt, that equals to negative 3 sine 3t, because we have cos 3t, so derivative of cos is negative sine, multiplied by derivative of the inner function, derivative of 3t is just 3, so we need to multiply by 3. So negative 3 sine 3t. So in the case of square root of tan of t over 2, we could rewrite that as tan t over 2 to the power of 1/2. And we need to take the power down to the front, so 1/2. And we need to take the 1/2 power down by 1, which becomes negative 1/2. And we need to multiply by the derivative of the inner function, which in this case is just sec squared t over 2. Because the differentiation of tan is sec squared. So we'll have 1/2 times tan to the power of t over 2 to the power of negative 1 over 2 times sec squared t over 2. If we simplify that equation, we know that to the power of negative 1/2, that's the same as saying 1 over square root of that same thing. Because if we have a negative power in the numerator, we can move it to a positive power in the denominator. We know that sec squared t over 2 sec squared is the same as 1 over cos squared, so we'll move that to the denominator as well. Alright, so what we actually have here is negative 3 sine of 3t plus 1 over cos squared t over 2 times 2 times tan t over 2 to the power of 1/2. If we substitute pi over 2 to find the gradient, we'll get negative 3 sine of 3 pi over 2 plus 1 over cos squared pi over 4 times 2 times tan 10 pi over 4 to the power of 1/2. So in this case, you can just plug all the numbers into your calculator. So sine of 3 pi over 2 is just 1. So sorry, it's not 1. Sine of 3 pi over 2, that's just -1. And -1 times -3, that's +3. Cos of pi over 4, that's root 2 over 2. But if we square root 2 over 2, we'll get 2 over we get 2 over 4, which is 1/2. So the cos squared pi over 4 is 0.5. And if we multiply that by 2, because we have the 2 at the bottom, so 2 times 1/2, tan pi over 4 is just 1. 1 to square root of 1 is just still 1. So 1 to the power of 1/2 is still 1. So we have 2 times 1/2 times 1. So we have 3 plus 1 over 1, which is 3 plus of 1, which is 4. So we know y equals to 4. Okay, I should say y equals to 4t plus c. Apologize, it's not x. Apologize for that. So I should say y equals to 4t plus c. And we need to find the y coordinate at pi equals to 2, pi over 2. So substituting pi over 2 into our y equation, so our graph equation will get that we'll get cos of 3 pi over 2 plus square root of tan pi over 4. So in this case, cos 3 pi over 2 is just 0. And tan pi over 4 is 1. Square root of 1 is still 1. So it equals 2. So y, or if we substitute pi over 2 into y, we'll get 1. So if we substitute 1 back into our equation for y, we'll get that 1 equals to 4 times of pi over 2 plus of c. Because we're finding it at the point t equals to pi over 2. So when t equals to pi over 2, y equals to 1. And if we rearrange for c, we'll find that c equals to 1 minus 2 pi. And that means y equals to 4x plus 1 minus 2 pi. And that's our final answer. Alright, so example 3. Sorry, I don't know why that's showing up there. Okay, so the number of calories burned at any time during a rigorous training session can be modeled by c of t equals to 2t minus 1 squared minus t squared plus 1 to the power of 1/2. When was there the least calories burned? Alright, so when you're trying to find a minimum or a maximum, we need to differentiate and make equal to 0. And we covered that in very great detail in level 2. So differentiate, make equal to 0, and that will be when it's a maximum or minimum. And we can either do the first derivative test or the second derivative test in order to determine whether that turning point is a minimum or a maximum. So we make differentiate first, so dc over dt, so in this case, 2t minus 1 to the power of 2, we'll move the power to the front, it becomes 2 times 2t minus 1, take the power down by 1, so 2 becomes 1, multiply by the derivative of the inner function, the derivative of 2t minus 1 is just 2. For the second one, we'll move the 1/2 to the front, so it becomes 1/2 times t squared plus 1, 1/2 becomes to the power of 1/2 becomes to the power of negative 1/2, multiplied by the derivative of the inner function, which is just 2t. So dc over dt, that equals to, if we simplify everything, we'll get at minus 4 minus t over t squared plus of 1. So in this case, we can multiply everything by square root of t squared plus 1. And so everything, including the left-hand side, but 0 times anything is still 0. So on the left-hand side remains 0. And we multiply everything by t squared plus square root of t squared plus 1. So we'll get 8t minus 4 times of square root of t squared plus of 1 minus t, because if we multiply t over square root of t squared plus of 1 by square root of t squared plus of 1, they will cancel each other out and you'll just get minus t. Alright, so in this case, we'll move the t by itself to the other side, and we need to square both sides, okay? So once we square both sides, we'll have t squared equals to 64t squared minus 64t plus 16 multiplied by t squared plus of 1. Alright, at this stage, we just need to expand the brackets. So we expand out, we get t squared equals to 64t to the power of 4 plus 64t squared minus 64t to the power of 3 minus 64t plus 16t squared plus 16. And if we join the like terms, so if we join the like terms and then move the t squared to the other side, we'll get 64t to the power of 4 minus 64t cubed plus 79t squared minus 64t plus 16. And we solve that equals to 0. So once we solve equal to 0, we'll have t equals to 0.5611, 0.488. So in this case, we could either differentiate again and use the second derivative test, or we can just use the first derivative test. So usually in CAA, if they told you to prove they don't usually tell you to prove there's a maximum or minimum, but if they do ask you to show that there's a maximum or minimum, we can just simply use the first derivative test, and that's easy because we don't have to differentiate again. Because if we use a second derivative test, we have to differentiate the function again, and as you can see, if we do that, it becomes a lot more complex. And that increases the chance of making a mistake. So if we use the first derivative test, all we need to do is substitute a point slightly below the turning point, and substitute a point slightly above the turning point. So if we start off with 0.5611, we'll choose a point slightly below that, so we'll say 0.55, and we'll say a point slightly above, which is 0.57. So we know that this is a gradient function. dc over dt is a gradient function. And how the first derivative test works is that you're trying to find whether the graph is increasing or decreasing below this turning point, and whether it's increasing or decreasing above this turning point. If you look at the shape of the curve, if it's going from increasing to decreasing, then it's a maximum point. If it's going from increasing, if it's increasing and then going to decreasing, then it's a maximum turning point. And on the other hand, if it's going from decreasing to increasing, then it will be a minimum turning point. So in this case, if we substitute 0.55 into our derivative, we'll get negative 0.0819. That means the graph was decreasing at 0.55. When t equals to 0.55, the amount of calories was decreasing, okay? And if we substitute 0.57, we'll get 0.0648. That's positive, which means that at t equals to 0.57, the amount of calories was increasing. So the rate of change of calories is increasing. So basically, we just went from decreasing to increasing, which means that the shape drawn out was a minimum turning point, which means that we found our minimum turning point. On the other hand, if we substitute 0.4488 back into our equation for our gradient function, we'll see that it equals to negative 0.819, which is not 0. So the reason that we're getting this turning point, and it's not actually a turning point, is because once we square both sides, so once we're trying to solve for t is 0, once we squared both sides, if you remember back to our complex numbers, when you square both sides, you create an invalid solution. So by squaring both sides, we created an invalid solution, and that invalid solution was 0.4488. It's not actually a turning point. Okay, it's just an invalid solution created by squaring both sides. So our answer to this question is when t equals to 0.5611. Alright, so that's all I have for this video. I hope you enjoyed the video, and I hope to see you all in the next one. Thank you. Bye.